To do this, I would put it kind of in 4 steps. You can write them down or not. It's not like a theorem or anything. It's just you can organize it. So thinking back what all we've done the past week and a half, if we're gonna find the zeros of a polynomial, say we're asked to find the zeros of this, for instance, what do you think would be the first thing we want to do, maybe? Okay, that would be one thing we're definitely going to do. Yeah. So find the possible zeros. Okay. What's another thing we can do? What did we do the day before that? Yeah. So we figured out how many zeros there are, right? So it'd be probably good to know how many we're actually going to try to find. How many we're going to try to find? If they're positive, if they're negative, if they're imaginary, that might be helpful because then when we make our list, if we know this many are positive or this many are negative, that's going to help. All right, so let's start with that. Let's start with how many we have. So that's going to be our first step. Determine how many positive, negative, and imaginary zeros we have. Be a good place to start. So when we know I'm looking for this many positive real zeros, this many negatives, so then we'll know if we got them all. We'll also write the total as well. It's kind of just insinuated in that, the total number. So this was forgotten. This is the Descartes rule of signs. So we need to know that. That's from Monday. Descartes rule of signs. Remember that's where we're looking for the sign changes. After we do that, then we'll do the other thing we just talked about, what we did yesterday. We're going to list out the possible real rational zeros. Real rational zeros. That's the rational zero theorem we just learned. Zero theorem. All right, and then prior to this week, we'll learn something called synthetic division, right? Remember how we could test factors? So if we've got a list of the possible ones, well, then we could start testing them and see if they are. So that's what we're going to do next. We're going to find one of these real zeros using synthetic division. So we're going to just test ones we think might work, test it out using synthetic division. Then after we've done that, we're actually going to have sort of like a simplified version of our polynomial. So then we're going to try to either factor it if we can, or there's actually hints might need to use the quadratic formula. This is probably the hardest part down here, remembering how to factor, use the quadratic formula. Both things that you've learned, but I know it can be a little rusty. All right, so anybody remember the quadratic formula? You had to write it out. I'm sure you memorized it at some point. Maybe take a second and see if you could write out the quadratic formula. I think you could do it if you had to. What if you got $1 million to figure out the quadratic formula? You can at least know the general setup of it.
I think money buys happiness, Mr. Davis.
No, I didn't say you'd be happy. I said
You know the thing is, I wouldn't have $1 million.
All right, what does it start with there?
Probably a letter.
Yeah.
It starts with either a letter or
So
a
F.
So we'll say x equals.
$1 million.
All right, let's piece it together. Then what?
Square root of something.
What's the square root in it? Okay, negative b plus or minus the square root. Yep, b squared minus 4ac.
All over today.
Oh, good, all of today. So you did this class, good job.
So do we all split
Do it
$1
as
million?
you-
Or?
Yeah, I don't have $1 million to give you. Sorry.
So do I.
I said if you could, but Eric couldn't do it, so.
I think anybody in here is doing it. Pretty sure. I saw a lot of Google tabs open.
Huh?
I saw a lot of Google tabs open.
Alright, that's it.
That's it. I don't think there's a thing called tutors going on.
Honestly, not.
Yeah, it's kind of vague, huh?
So if I could have done that, I would have done
Alright, so let's see if we can do this. So there's a lot happening in one problem. Right? Pretty much everything we learned last week. So we're gonna find the real zeros of this, and then we're gonna try to write it in what we'll call factor form. Remember when we did that Desmos activity, we wrote it in factor form, like all the different x plus 2, x minus 5. That was factor form. All right, so let's start by writing out how many zeros, how many positive, how many negative, how many imaginary.
3 0.
Yep, so total is going to be 3. Okay?
Actually,
I'll just shoot for
sign
Positive,
changes, but I'm
real.
talking about the positive real zeros.
Yeah, positive real is going to be, one sign change. So it'll be 1, either 1 or anything, just 1. No or because it's not 2. If it was 2, it could be 2 or 0. Yeah, just 1 positive real. All right, now negative real, remember you have to do f of negative x. Maybe you can do that in your head, maybe not. I'm going to write it out. But if you can figure that out in your head, that's fine. You can just write it out. So we got to do f of negative x. Remember, if it's an odd number of negatives, it'll be negative. So this is 3, right? So it'll be negative x to the third. An even amount will make it positive. So this is 2. So that's even amount like plus 2x squared. Here's an even amount to 1, 2 negatives make it positive. And then minus 6. So then how many sign changes? 1, 2. All right, so negative real is going to be 2, or it could be 0. And then imaginary, we've got. Yeah. Imaginary isn't that important for this because we're just going to find the real one, so it doesn't matter, but we'll go ahead and just state it. So if we had 1 and 2, that would be 3, so that would be 0. Or if we had 1 and 0, that would be 2. 0 or 2. Okay, first step done. Check. All right, next step is to list out the possible zeros, which we did last night. So let's go ahead and do our P. P is the factors of the constant, or the factors of 6.
Mhm.
Yep. We got 1, 2, 3, 6. And our Q is pretty easy, it's 1. So that's obviously it's 1. So our list of possible real rational zeros is plus or minus 1 over 1, 2 over 1, 3 over 1, 6 over 1. So I'm just going to write it as possible go ahead and simplify them. 1 over 1 is 1, 2 over 1 is 2, 3 and 6. All right, so that's a good starting spot. Now we've got to find one. So there's no necessarily shortcut to this, necessarily, other than we got to just guess and check one of these you think might work. So where do you guys want to start? You want to try 2? Okay, let's try 2. Generally, I normally try 1 to start, but sometimes you can just plug 1 in your head. If you plug in 1, this will give you 1 plus 2 minus 5 minus 6. Is that going to give you 0? No, that's not going to give you 0. There's way more negatives than positives, right? Let's try 2. Let's try that. So for 2, we're going to just put the 2 on the outside, and we're going to try with synthetic division. You could probably, you might be able to do this in your head, but I do want you to show your work with the synthetic division here. So then we write out the coefficients, remember? Just make sure it's in order 3, 2, 1, 0, 2. So 1, 2, negative 5, negative 6. Now we're just doing 2, so we're writing 2 because that's the 0. We're not doing the opposite of that. So this would be 1. All right, 2 times 1 is 2. Add those two together. 4. 2 times 4 is 8. Negative 5 plus 8 is 3. 2 times 3 is 6.
0.
All right, so that's good. Now you also have to, yeah.
How did you know that these ones
We just guessed. Josh just had a hunch. Too.
I have a question, because I accidentally plugged it into the actual equation.
Huh?
And it equals 0.
Yeah, you're still gonna want to do this though. You're still gonna, yeah, it's the same thing. Yeah.
Oh, okay,
Yeah.
so that's how I got it right.
But you're still gonna want to do that because then these numbers are gonna be important.
Okay.
So this is good. This is what we want. We got a 0. It's good. That means we found one of the zeros. 2 is a 0. All right. But if you remember when we did synthetic division, I told you that these other numbers were actually kind of important, right? We're going to use these numbers to write a new equation. So with these numbers, these are actually the coefficients of our new equation, our new polynomial. This 1 becomes our first term. This is going to become 1x squared, and I'll explain it to you in just a sec here, plus 4x plus 3. You can write it like that. All right, so you can see what's happening here. I didn't start with x cubed, I started with 1 less than that. I started with x squared because we sort of like divided out one of the x's. Okay, so I'm starting with x squared because our original term had an x cubed, and so it's 1x squared, and then I just work my way down, plus 4x plus 3. So this is my new equation, and what I've also done is with this 2, found that that's a 0, x equals 2 is a 0. I've sort of like factored it out like this, x minus 2. So I'm going to write it like that. So we're kind of working towards our factored form. So I've sort of factored out that x minus 2, and this is what you'd be left with. All right, and then what we're going to try to do, our last step then, is to try to factor what's left over. Anybody factor this? And this is like 7th grade factoring.
What's x?
Yeah, that was wrong. That was wrong.
It's not
So x is the first number.
okay. So factoring with 3 terms, you think what multiplies to give you this and adds to give you that.
Yeah.
1 and 3, right? So x plus 1, x plus 3. So this, I'm going to write it with f next. F of x, that's our factored form. So f of x equals x minus 2 times x plus 1 times x plus 3. And so that's our factored form. We also need to identify the zeros. So our zeros are, well, we found the first one was x equals 2. And then what would be our other 2 zeros? Using this factored form.
3, 1, negative 2.
Negative 1 and negative 3.
Oh, this.
So that's like the easiest possible problem you could have in this. I know there's a lot of steps, but the easiest possible because it factored really easily. and we guessed right on the first time and got a 0. But that's all the steps. We listed how many, we listed the possible, we did synthetic division to try one, and then we factored it. So we did all 4 of those steps. All right, let's try another one.
What do we get at x minus 2?
So this 2 out here tells us, if you remember when we did like the factoring, if 2 is a 0, if x equals 2, kind of working the opposite, it would be like x minus 2 equals 0. So like it tells us that x minus 2 is a factor. All right, let's try another one. Also, just to point out something. Sorry, before I said positive real, we said 1, right? 1 positive real.
Okay.
Negative real, 2 or 0. Look, 2 negative. It all works. After tomorrow.
We'll take a quiz on.
Do you have a quiz tomorrow?
Not a quiz, no.
The graded assignment.
All right, let's try this one. So start by identifying all of the factors. I mean, all of the number of factors. So it doesn't really matter the order you do those. All right, total was 3 again. Yep. Positive real. So we got 1, 2 sign, 3 sign changes, right? Yeah. So it could be 3 or 1, right? Here 1. Negative real. You do want to do the f of negative x. Simplify that. So we've got an odd number, so it'll be negative. This is an odd number because we have 2, and then another one's 3, so it'll be minus 13x squared. This one's an odd number, which is 1, so minus 4x minus 9. Yeah, so none negatives. Now that's helpful because that means when we test them, we shouldn't test the negative number, right? Right. And then, so imaginary, and this isn't really necessary for this, but I'll go ahead and say. If there's 3 positives, there'd be none. If there was 1, there'd be 2, right? All right, so let's then make our list of possibilities. So we got our P. Factors of 9 are what? Good. 9. Our Q. 1 and 2, right? All right, so then our possible are going to be plus or minus 1 over 1, so plus or minus 1, plus or minus a half, plus or minus 3, plus or minus 3 halves, plus or minus 9, and plus or minus 9 halves. There we go. So when you're guessing, generally you probably want to avoid fractions, at least to start, right? Not do a fraction unless you have to. Fractions are just harder. And we know they're positives, so I would choose to start either probably 1, 3, or 9. You want to try 3? Okay. And 1 is generally pretty easy to do in your head because 1 is just would make this 2 minus 13 plus 24 minus 9. Did I give you 0? Can anybody turn that? I'm sorry.
No, it would have been 4 and 9.
Yeah, what I think it give you like 2 or something, or 4 or something, right?
Yeah.
So 1 doesn't work. I just generally try that in my head first. So then let's go ahead and try 3. 3 seems like a logical choice.
I'd say 3 would help.
Yeah, 3 probably is, but I'm just saying 1 you can generally do in your head. 3 you might not be able to do in your head. So I've got 2, negative 13, 44, and negative 9. Just double check it's not skipping any. 3, 2, 1, 0. So we're next. Then you just go through your synthetic division. Bring the 2 down. 3 times 2 is 6. Add 1 again, negative 7. Times negative 7 to negative 1. Add 3. There we go. Whoa. All right, so that's good. We found the 0. Now we're going to write it in factor form. The one bummer with this one is when we write it, it's going to be 2x squared minus 7x plus 3. So that's what we have left over. And over here we got x minus 3. The bummer is that we got a 2 in front of that x squared. So it's not as easy to factor. Anybody know how to factor that?
You do 2x on one side and x on the other side.
Okay, so you just want to do the guess and check then this way? Alright. So in order to factor this, we can't just think what multiplies to give you that and adds to give you that because we have a 2 in front of here. So Eric's saying is we'll put a 2x with one and x with another. Okay, so because we know there's got to be a 2x and x because they got to multiply to give you 2x squared, right? Okay, now you can try to guess and check. There is a way you can actually do this, a more scientific way of doing it. But if you want to guess and check, it still has to be factors of 3, right? So only factors of 3 though are 1 and 3, right? Okay. So we know we got to have a 1 and a 3. We just don't know which place. So let's just try. If we have a 1 here and a 3 here, that's going to give us 6 and 1. This does give you 7, so that's good, right? Now if I switched it, I'll just show you here. If I put the 3 here and a 1 here, this would give me 2 and 3, which is 5. And I gotta get the middle, I'm trying to get the middle term. So I definitely probably want to try that. Oh, we had it to begin with, right? So 3 here and a 1 here. Now what sign should they be?
Negative 3 and positive 1.
Both negative. Because 2 negatives, think about foiling, 2 negatives multiply to give you a positive, and minus 6 and minus 1 gives you minus 7. Right. So the more scientific way of doing that, there's a number of ways, depending on whoever taught you how to factor. One way is that you multiply like the a times the c. 2 times 3 gives you 6. And you write, this is called like the big X method. Anybody ever learned something like this? Maybe a little bit differently, but you multiply the a times the c, and then you write the b on the bottom, so negative 7. And then you think what multiplies to give you 6 and adds to give you negative 7, which would be negative 1 and negative 6. And then you split this middle term up using those two. So then we write it as 2x squared minus x minus 6x plus 3. So you kind of actually expand the middle term. And then you factor by grouping, where you pull out a common factor, which is going to be x here. And then we're left with 2x minus 1. And then over here, the GCF is minus 3. We're left with 2x minus 1. And you pull these together, you get x minus 3 and 2x minus 1. Anybody do anything else with that? We can't spend like forever factoring in this section, so don't worry about it if you don't get that. Because we could spend like 3 days just factoring. We can't do that. Anyhow, you can probably just guess and check on this if you're fine. So bring that down. And then so that's our factored form there. f of x equals this. And then our zeros, and actually notice, what do you notice all those factors? Okay, and what else? Yeah, there's x minus 3 twice, right? So we can actually write this as x minus 3 squared times 2x minus 1. Is that right? What does that mean if it has a squared there? Well, 2 of them, what would it mean for the graph? Huh? Well, it's the cubic overall, though. What does it mean if you have a... Does it cross or does it touch? It touches, yeah. Remember if it's like squared, that means it touches and bounces off. It's called a repeated root. It's the same root twice. It's a repeated root. So our solutions are 3, right? The 3 is actually a repeated root, so it kind of counts as 2 because it's squared, right? And also, now this one you have to solve. You might need to do this on your own. 2x minus 1 equals 0. We solve it, we get 2x is 1, so x is a half. So that's your other root. So there's 3 positive reals. One of them counts twice, the 3 does. So that's the extent of the. There's obviously harder problems, which we'll do tomorrow, but those are the 2 basic ones. I want you to try 2 problems like this tonight and whatever's left of class here in about 10 minutes. So I want you to try 2 of them, and again, like I said, we'll do harder ones tomorrow. But I believe the 2 that you have are very similar to this. Let's skip these 2. So start on them in here in class, and then you can ask for help if you need it. But still stuck on page 214. We're going to do numbers 52 and 54.